Today, I'm going to talk about the GRF2176 and some ways that we've discovered that can help with tuning to achieve some flatter, more stable performance than what we've seen in the past. Okay, the GRF2176 is an LNA. It's an amplifier that has a high gain mode and a low gain mode. It is very good noise figure performance, around 0.6 dB, and it can be used in a variety of applications. Frequencies up to 6 gigahertz or so. And it's, yeah, that's about it. I very high level. Okay, so our standard tune in the data sheet is 3300 to 4200 megahertz. Typical gain is around 32 dB or so. It does have a bypass mode, which knocks the gain roughly in half to about 16 dB. P1 is around 18, 19 dBm, and OIP3 linearity is low 30s, like 32, 33 dBm. But the noise figure is very good. Sub 1 dB, we see around 0.6, 0.7 dB in this frequency range. We've seen even lower if you tune it in lower subbands, and it's just a product that, if you're looking for very low noise and high gain above 30 dB, this is a part to really consider. At Guerrilla RF, the applications team is always looking for ways to improve on tunes and try to simplify for the customers. And recently we've come across some methods that have helped other products achieve more stable and better performance. And we've applied those same techniques to this part, the 2176. And one of the things that we've noticed is that, especially for higher frequency tuning, the use of 0201 components on our evaluation boards has been really helpful. We're seeing that some of the 0402 packages have some parasitics out of band that have been negatively affecting how we tune for our gain flatness, our return losses, and the 0201s seem to have a cleaner output in terms of gain flatness and return loss. So any kind of input or output matching component that's critical to achieve frequency response, we've swapped out those components with 0201. The DC feed choke has also been a critical factor, that the 0201 component tends to have a higher self-resonance. So that allows you to tune higher frequency without having to worry about the component itself disturbing the tune in band. So in summary, just trying to replace input components, output components, and the DC feed chokes with a 201 has demonstrated easier tuning and better performance for our parts. I think the 201s typically have lower parasitics and higher self-resonant frequencies that basically can shift some parasitic performance out of band. So the 0402s tend to be pretty good for tuning below, say, 3 gigahertz or so. But as you get above a certain level, they can be favorable or they could be detrimental to your tune, depending on how all the impedances line up. Where the 201s, we've seen that we haven't really had to deal with any adverse parasitic like we have with the 0402s. So it's just been able to help us achieve a cleaner tune, better return losses. We haven't had to have special shunt resistors or any kind of circuitry that would help calm down a circuit. So we've actually been able to reduce a few components on our standard tune by using 0201s, simply because we haven't needed some of these extra resistors or inductors that were helpful for stability and other flatness techniques. Higher frequency tuning, it tends to roll off above 5 gigahertz or so. Tends to be more difficult to tune at those higher frequencies. And I think on the low side too, if you go below 2 gigahertz, it can be a little more challenging. So it kind of like the 2 to 5 range is the sweet spot for tuning this particular LNA. We had some difficulties in the past getting stable across a wide variety of frequencies. The 0201s and some of the tricks that we've come up with recently have helped make those easier to tune. But for the most part, we've been able to help make this part. It tends to behave pretty well, like I said, between like 2 and 5 gigahertz. It sometimes achieving enough bandwidth could be a problem. It does have a pretty good wide band between 3.3 and 4.2. I think gain flatness within about dB.5 across that band, which is for 900 megahertz, and that percent bandwidth is pretty good. But if somebody wanted a wider tuning bandwidth, that there could be some limitations going wider than that, or flatter. If they need it less than a dB of gain flatness, that could limit some of the performance as well.
Thank you so much for watching. If you'd like more information, please email us at sales@guerrilla-rf.com. And don't forget to subscribe to our channel for more content from Guerrilla RF.